Welcome to Air Science. It is time for Lab 2, Density of Liquids. So we're going to be checking out the density of alcohol, vegetable oil, Dawn, water, and salt water, which I made by dumping salts into water. Just like solids, same deal. To figure out density, we need a mass and a volume. And I'm not even going to make you work hard on this one and do some backwards. We'll just get the mass and the volume of 5 different liquids. However, there's a trick. If I want to get the density of that water, I guess if I want to get the mass and the volume of that water, I can't really go and just dump it onto this balance and expect anything to happen. Well, I guess I can expect something to happen. It's going to make a mess. So we've got to figure out a way around that by subtracting out what's in the glass. So in other words, if I know that this beaker number 1 for the alcohol has a mass of 22.7 grams, and then I go and I put some alcohol into it, and if I can pull this all off with one hand, it'll be a small miracle. We'll see. This one's got a nice pour. I'm gonna have to put the phone down a couple times because I'm gonna make a mess here, but now I've put some alcohol into it, and lo and behold, I've got a higher mass. So can you use your noggin? Can you use your noggin and figure out what the mass of only the alcohol, only the liquid is? Which you should be able to do. And then what we gotta do is look and see what the volume of it is. And I'm probably gonna want a nice simple background for this. So this is a nice small graduated cylinder. These have an increment of 0.2. So like for example, there's 6, 6.2, 6.4, 6.6, 6.8, 7, and so on. 7.2, 7.4, 7.6, 7.8, 8. So I'll let you figure out using the meniscus about what you see in there. Sound good? And that's it. That's beaker number 1, alcohol. So now we'll just do that 4 more times and you're good to go. But again, I'm probably gonna have to put the phone down when I pour because that was a little bit messy. So beaker number 2 for vegetable oil, empty. There's the mass. Now please hold. If I knew how to pause that, I would do that. Sorry for this part, guys. Maybe you'll learn how to use fast forward. There it is. And for a volume, for beaker number 2. There you go. 2 down, 3 to go. Beaker number 3 is going to be Dawn. There it is, empty. Might be able to fill this one with one hand. Nope. I bet you I can wipe it down with 2 hands. I'll be back. We wouldn't want that on the outside because then there'd be more mass, but less volume in the tube. So there we go, fixed. Now we've got that as a mass. You know what, maybe we're gonna come back to this guy in a minute. Look at all those bubbles. It's not really gonna give us an accurate reading. Pump the brakes on that one, press pause, we're coming back later. All right, 4. There it is, empty. This one's gonna be just plain water. Now, water, the way they set up the metric system was once they invented what the meter was, they made everything based on that. So a centimeter, a cubic centimeter, that size, 1/100 of a meter, and then you make a box 100th of a meter by 100th of a meter by 100th of a meter is a 1 cubic centimeter box. Then they said that's also going to be what a milliliter is. So if this comes out right, which, you know, given that maybe there was an error on the first reading, maybe there was an error on the second reading, and maybe there's an error in how much water you guys see is in there. But if it comes out right, 1 cubic centimeter is 1 milliliter, and 1 milliliter should have a mass of 1 gram, which means density of water should be 1, like by definition. Are we going to get that or not? We'll see when you crunch the numbers. Next is salt water. Give it one more stir here. While you check out the mass of the empty cylinder. Chuck that in the sink. And let's see how we do. So what should be the density of salt water? It's not just water, it's salt water. A couple of bubbles there. There you go. Did I do the mass? So there you go. That's your salt water. That's beaker number 5. So I think we're pretty much done, with the exception of if we want to go back to the Dawn beaker number 3 and just try to get a better look, although it's still pretty darn bubbly. So just have to do the best we can do. There's less of a meniscus with water has a meniscus because of its polarity, so you don't really have to worry about the meniscus here. So that's probably 8, right on the money, 8 milliliters. All right, hopefully I got it all. If I didn't miss anything, that should do it for Density Liquids Lab. Retro He-Man guy says, thanks for paying attention this long. Welcome to Air Science.